Hi, everybody. My name is Roman. I will tell you about my experience of using Toloka for the recommender system development in e-commerce. What you will learn from my presentation, how to use all of your data for the recommender system development without losing relevance. We will talk about soon. Next, how a crowd power could help you in that, and how to measure a visual relevance for recommendations. This is a very interesting topic because it's not scientific, but this is a little bit a subjective measure of recommender system of recommendations quality. So some words about me. I was a head of analytics of the largest e-commerce store in Russia. Now this company is evaluated 10 billion on NASDAQ. Next, I founded and exited from a company Retail Rocket. I was responsible for recommendations, algorithms, and data in this company. And now I'm doing my own project about data analysis. And also I wrote this book in Russia and in English. It's available in Amazon. This is I hope a good introduction to data science for managers, startup founders, and newcomers. This book is written without any code and almost without math. I think it's very interesting. So some words about my previous experience, because I will tell you about it. I will tell you about my Retail Rocket experience. So Retail Rocket is a company which is a provider for e-commerce sites, which is a provider of recommendations. It is a SaaS service. Just we did all the recommendation engine job for our clients throughout the world. We have different offices in Europe and South Africa, 1,000 clients, 150 employees, and so our goal is to provide the best recommendations for e-commerce as possible. And a typical recommender system in e-commerce looks like this. This is a typical data flow diagram. So it gets two data types from e-commerce sites: items data, all informations about items and tree or categories, and users data, which is gathered by our JavaScript counter. It tracks all user activities, clicks, page views, adding items into baskets, purchases, and so on. So I think you understand this. And after getting all the data, this computational cluster every night calculates so-called static recommendations. So what is this? Static recommendation, it's the bricks of any recommendation services. The most important algorithm, it includes popular items, customer who viewed this item also viewed similar items, and so on. But the most important, a complicated algorithm from my point of view, is the related items. It recommends additional items for the current one. So the related items is hard to calculate with good quality and coverage. So if you are going to choose a recommendation engine for your company, for your service, so I have a hint. Just the best way to compare a different recommender system, just compare the related item algorithms, because this is a state of art in this area. So our data is dirty because a typical number of people who make a purchase on the site, it's about 1% of all visitors. So that's why it's hard to find helpful signals in this noise, especially for related recommendations. Also, we have different metrics. This is a well-known, the third one is a well-known metrics which they are recall, which help to assess the quality of forecasting of the next step of the user. Diversity means the diversity of different types of products in the list of recommended items. Coverage means how many items have recommendations. And very interesting thing is it's a visual relevance. Visual relevance means how the recommendations attract the user or the people, for example, who just want to buy something. This is a very subjective measure, but it's very important. And but at the end of the presentation, I will tell you how we calculated how finally. So it's about metric. So we have 4 metrics. Next, the key dilemma in our field is about low statistics or long tail. So as I mentioned before, the user data is dirty, so it makes hard to find a signal in this noise. Let's look on the graph. The most items get only few events. This is a right area. This is a long tail, but some events are getting some items are getting bestsellers. This is the left side from the red line. So the easiest way to make a quality recommendation just to cut out the tail at some threshold. This I marked it with red line, but in this case we lose a coverage metric. The most of items would be without any recommendations. So this threshold affects all metrics in this way. Just if we put the threshold to the writer, the coverage would be better, recall and visual relevance would be worse, and vice versa. So this is a very complicated question because in many cases we don't have enough data to produce very good recommendations, especially for related case. So let's see on this slide. So we have a drill, and other items are recommended by some recommendation engine, just beads for drill, diapers, cat's food, and hammer. Okay, let's think about what are the good items, what are not. So beads for drill. I think this is a perfect recommended items. Diapers. It looks very strange. Food, cat's food. Very strange. Hammer is good, no, not so cool as beads, but it looks very good. So I demonstrate to you how people can help you from the crowd can help you to filter out such bad examples of recommendations. Okay, how to get rid of them if we want to use all of our data? So we could one way, okay, just from the beginning, when you have a lack of data, you don't have enough data for your recommendation engine, you could try to use all the data. You could produce all these recommendations, but the recommendations I itself are dirty. So that's why you should create some rules over it to filter out bad recommendations. At first we tried to do that at the category level, just to remove some pairs from related items like tool and kids goods, tools and animal goods, and vice versa. So why not? This is a very good way to get rid of the not looking good recommendations. So for that case, about 7 or 8 years ago, we built up our crowd service. Because it's a hard job to assess all the possible category pairs. So our developers built up a service and website for this. We hired 5, maybe 10 assessors who will check all possible pairs full time. Each task requires 2-3 assessors to get robust estimations, because we cannot leverage on only one person opinion for any pair. So, and they could work on categories level only. After some time, maybe 2 or 3 years, we found out the disadvantages of our internal solution. The first one is a very low speed of assessment, up to a month for non-Russia site. It's a very large number for us. And then second, we couldn't measure visual relevance, because we were working on the category level only. So about 4 or 3 years ago, we heard about Toloka and decided to try it for that. And finally, what we got? We got a full outsourced service, so we don't need to ask our internal developers to fix some bugs or make some features, because we have a huge queue of tasks. So that's why it's not good to be at the end of this queue. We will lose our speed of development in this case. Also, any task at this point, any task could be assessed within hours rather than a month. It's very important, because we could hire thousands of people who will check our recommendations. And also, some categories in e-commerce are pretty large. I have seen 10,000 items in categories. So we decided sometimes it's better to work on the item level, and Toloka allow us to do that. And also finally, we found a way how we can assess a visual relevance metric as weighted estimates. So it really helped us to analyze our algorithm improvements when the major metrics keep their values. For example, you could conduct some A/B tests just to assess a new version of recommendation algorithm. Okay, after that, you got results and see that all major metrics are almost the same, but what's about the visual quality of these recommendations? This is subjective metrics, and we have that. It's also very important for us in terms of sales, because if you are going to some people who has a right of making decision about buying our project for the company, they pay attention on a list of recommendations, just ask us to prepare some cases, and also they pay attention on this visual relevance. And in some cases, when they found some bad cases, they decided not to deal with us. So it was that. So that's why visual relevance is for us. It's a very important thing. So this is an example. This is a real screenshot from the real task. And this is an example where we asked assessors to estimate the relevance of each recommended item. So we have one base item and just ask them for any item, for any recommended items. There are six items, just to mark it like as a very good related item, not good related item, and I don't know, and something like that. And after that, we could calculate the weighted estimates, weighted averages over these assessments to calculate these metrics. So, my conclusion. If you want to create the best recommendation algorithm, it's better to leverage on all your data which is available to you. It's hard. It's hard because it's easier to create good-looking recommendations just to cut off items with low statistics, but it's not good for in terms of coverage. So you will get about 10% or 5% of your items will be covered by a related algorithm. Also, not just use a crowd power to filter out your bad recommendations. It's a very good practice and it works, and I found it very helpful for us. I have also an idea to create a commercial product. Just if you want to very polished related recommended items, just use Toloka for that, and just to resell it. And also I shown you how to measure a visual relevance of recommendations. It's very interesting because I haven't seen this metric in any REXIS conferences. I have been at 4 REXIS conferences in Vienna, Boston, and other cities. REXIS conference, this is a worldwide conference organized by Netflix, Amazon, and Google about REXIS, recommender system development. So from my point of view, it's very important because this subjective estimates matters for people, matter for people. So thank you. If you're interested to try to see my book, just this is a QR code to it. Also, I have my email, Zykov TopDataLab, or you could subscribe to Twitter, just Zykov, just as the first word in my email. So I'm finished.